Hello everyone, and welcome to this brief overview of our CS385 Mobile Application Development project. My name is Firoz Shafeen and I was the head developer of our project. My team comprised of Patrick, Éanna, Audrius, and of course myself. So as this year's CS385 group project was themed a sustainable environment, our unique project intertwines technology, health, and environmental awareness to ultimately help reduce carbon footprint. And so we've developed a website that allows the user to log in with their Google account, which allows us to integrate our website with their Google Fit data to track walking steps. It's not just a step counter, it goes a step further, as it converts your daily steps into something that has a measurable impact on the environment. Once the user has logged on, our website syncs their Google Fit data with our backend. Our website then calculates their total daily steps, their total weekly steps, and also the distance walked today in meters. Using this data, we can estimate the amount of carbon dioxide equivalent, or CO2e, the user has saved compared to other forms of transport. Here we can see the total daily steps I've walked today, the weekly total steps I've walked today, and also the distance I walked today in meters. Using these values, we calculated the total CO2e emissions saved by walking, and this is compared to a car. Using this data, we can estimate the amount of CO2 emissions we saved by walking instead of using a car. Down here we can see the emission comparison chart, and this shows us the amount of CO2 emissions we would have produced if instead of walking we took a mode of transport, such as an electric scooter, an electric car, a regular car, a bus, a train, or a plane. For even more data analysis, we can go to the data analysis page. Here we can see the user's daily and weekly progress over the months. We can see how many steps were taken each day and how much carbon emissions was saved as well. Adding graphs and charts like these make the user experience more engaging and makes it easier to understand large amounts of data that would otherwise be dates and just a bunch of numbers. We added two sync buttons, one that syncs an entire year's of Google Fit data from the user to our backend, and another that syncs only the last 7 days worth of data. The Sync All Data button can only be pressed every 5 days, whereas the last 7 days sync button can be pressed every 15 minutes. We also implemented a leaderboard of all users who have been using the app. That way there's a more challenging aspect to our website, with the hope to push individuals to take more action over their carbon footprint. We can sort by the daily, weekly, or monthly leaderboard for either step or CO2e saved. Moving on, we know that a lot goes into calculating distance traveled by the user. We wanted to make the data more tailored to the user, so we allowed the user to input their sex and their height. This helps calculate each individual stride length and how far each step takes the user. Lastly, we have a logout button. If the user does not log out, after 15 minutes, the website will automatically log out the user. The user is also logged out if they close the tab or browser. For the backend, we use MongoDB for its flexibility and scalability, allowing our backend database to efficiently manage the user's data and activity. Due to the complexity of our project and there being 4 people working on this project at any given time, it was important that we had a very organized and logically structured file system. This allowed us not to have to find a needle in a haystack every single time a new change or a new file was made. It was also important to name these files in an easy to understand manner so it wasn't obscure and we knew what each file was responsible of doing. The app.js file was our main parent component, and all other JS files were the child component of it. So from the home page, when the user presses the login button, it brings them to callback.js, which is the file here. This sets the authentication scopes for the fitness API activity read, the fitness location read, the user info email, and also the user info profile. So we're able to access all this information. With this information, we bring them to callback.js. Here we can set the Google ID, the first name, the last name, and the email. This is then sent into our database. After callback.js has finished executing, and if the user is authenticated, we're brought to the dashboard. If not, then we just go back to the home page. So in the dashboard, this is where we could see the total daily step data, the total weekly step data, and also the total daily distance that we traveled by walking. It's also worth noting that on the dashboard we have a conditional rendering where it shows the user an alert message saying that their step appears to be 0. This may indicate that the user's fit data wasn't updated properly or stored properly. However, the user can force store this by going to the data analysis page and pressing the sync all button to sync all their data. Here we can see the user schema that we use to store the user data in the database. We have the Google ID, the first name, last name, sex, height in centimeter, email, when the account was created, last time the account was logged in, last time all data was synced, and the last time the 7-day data was synced. Here we can see the leaderboard schema, and also we can see the daily activity schema, and also we can see the fitness activity schema here. We also have 3 different routes. These help pass data back and forth from the front end to the back end. Here we can see the auth contacts.js file. This is what keeps track of the user being logged in or not. Here we can see the session timeout limit. So we can see that we have it set to 15 minutes. And this is referenced throughout all the pages that we've used. The carbon calculator.js file is where we calculate the emissions for each different transport mode. Here we can see the emissions factors that we have set up, and then we multiply that by the distance to get the emission value for the specific transport type. The distance calculator.js file is where we convert the user steps to distance in meters. We take steps, the height of the person in cm, and also the sex. And these are all factors that play into the stride length. And that's about it. Thank you.